In this video, we're going to look at an example of using trigonometric substitution to evaluate a definite integral. So let's evaluate the integral from 0 to 1 of x squared times square root of 1 minus x to the 6. The first step is to rewrite this integral in a slightly different way and set it up for trigonometric substitution. So the integral will be x squared, and then inside the square root, instead of writing x to the 6, we'll write x cubed squared. X cubed squared is x to the 6. Then our trigonometric substitution will be x cubed equals to sine of theta. First, we want to look at the bounds of integration for a variable theta. X runs from 0. When x is 0, sine of theta is 0, which means that theta is 0. X goes to 1. That means sine of theta will be 1, and theta is pi over 2. So we'll integrate from 0 to pi over 2 in variable theta. Then 1 minus x to the 6 is 1 minus x cubed squared. Our substitution is x cubed equals sine theta. So this is 1 minus sine squared theta, which is cosine squared theta. That's what's going to go under the radical, replacing 1 minus x to the 6. Taking the derivative of x cubed, 3x squared dx. The other side derivative is cosine theta d theta. Therefore, x squared dx is 1/3 cosine of theta d theta. Now we have everything we need to write an equivalent integral in variable theta. It'll be integral from 0 to pi over 2. X squared dx is 1/3 times cosine of theta d theta. And then inside the square root, 1 minus x to the 6, or 1 minus x cubed square, that is cosine squared theta. And then taking square root of cosine squared is going to be cosine in this case. So this is from 0 to pi over 2, 1/3 times that. Cosine theta times cosine theta is cosine square theta d theta. That's the integral we have left. We're going to use a trig identity to evaluate this integral. Cosine square is 1/2 times 1 plus cosine of 2 theta. Integrated from 0 to pi over 2. And so this is equal to 1 over 6. Integral of 1 is theta. Integral of cosine 2 theta is 1/2 sine of 2 theta. And that's evaluated from 0 to pi over 2. Notice when we put pi over 2 into sine, that gives us sine of pi, which is 0. Putting 0 in there also is 0. The only thing left is 1/6 in the front, and pi over 2 when we plug in pi over 2. And so 1/6 times pi over 2 is equal to pi over 12, which is the final answer.